Good morning, everyone. So this is homework for Tuesday, October 31st, which is most of you guys who celebrate this should know is Halloween. This is the math homework for that day, Tuesday, October 31st. We're doing the fourth grade math homework. Let's begin. Okay, number one. Which number line best represents 6 over 8 plus 3 over 8, or 6/8 plus 3/8? So again, we have our denominator here. This bottom number is our denominator as usual. 8 is our denominator. That's just the total number of pieces. That's all that represents. We're going to add up right here. 6 and 3. So 6 plus 3. So we're looking for a line that represents the 6 over 8 plus 3 over 8. Now, we can get so basically we're looking for 6 plus 3. Okay, so let's look at this one. 1, 2, 3. 1. That's for this right here. That's one number represented. 1, 2, 3, 4, 5. That's 5. So this jump right here is 3, which is correct, which is something we might be looking for. But this second one is wrong. So we're going 1, 2 from this point right here. 1, 2, 3, 4, 5. So this is 5 plus 3. That's not what we're looking for. We're looking for 6 plus 3, right? Which is again right here, represented right here, 6 plus 3. 6 over 8 plus 3 over 8. The denominator isn't really that relevant in this. Hey, look at this one here. So starting from here, 1, 2, 3, 4, 5, 6. This is 6 right here. This big one is 6. And it's going back 1, 2, 3, 3. So this one here is 3. This is the two numbers, but you're looking at it's going back. So that represents you're subtracting. Instead of so we're not looking for anything for subtraction. They're going 6 forward, 3 back. And that leads us to this endpoint, which is again a subtraction. This would be 6 minus 3, which is not what we're looking for either. Let's look at the C. From 0. 1, 2, 3, 4, 5, 6. This is 6. Plus 1, 2, 3, plus 3. And it's going forward, so this is 6 plus 3. So in this case, this is the reason they're giving you the 8. I'll explain this to you right now. The reason they're giving the denominator 8, because there are eight sections in up to the 1 is divided into 8 pieces. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 equals 1 whole. That's basically why they're giving you that denominator. But that's not relevant to this. So again, our answer here is C, because we're getting 6 plus 3. So 6 forward, 1, 2, 3, 4, 5, 6 forward, plus 3 more forward from this point. 1, 2, 3. So 6 plus 3 equals 9, 9/8, which is exactly what it says. It represents 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, there's 8 pieces in the whole. So that's our answer, 9 plus 8. So this is the short answer of this. The answer is C. This D one here is wrong, because as we figured out with B, we're going back. So it's going whatever amount forward, but it's going back. So this is a subtraction equation, which is not what we're looking for. Again, this is our answer right here, C. And then that is, I'm going to run this by you again just to reiterate. So we're going forward from 0. 1, 2, 3, 4, 5, 6. Plus, because we're still going forward, plus from this point right here, 1, 2, 3. And that gives us our 9. This is 8 here. 8 is 1 whole, plus 1 is 9. So it goes 9/8. And that's why C is the answer, okay? Easy peasy. On to number 2. The pizza slices show the number of slices each kind of pizza Janelle's soccer team ate. As we can see, what we're going to do to get our denominator, the denominator is how many are there are total. So in order to get our denominator, we're going to need to count all the pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 total pieces, right? And I'm writing this on all of them because we're going to figure out the numerator, how many of each piece pepperoni, how many of each pizza there is in the total. So there are 12 total slices, right? We counted that. In pepperoni, there's 1, 2, 3. So 3 out of the 12 are pepperoni. 1, 2, 3, 4. 4 out of the 12 are veggies. 1, 2, 3, 4, 5. 5 of the 12 are cheese. Now we go to the question. Which expression could be used to determine the fraction of the slices that were pepperoni or cheese? So we look at this question. So we're looking for pepperoni and cheese. we can cut vegetarian because they're not asking about vegetarian, so we're not going to concern ourselves with that. So 3 out of the 12 are pepperoni, and 5 out of the 12 are cheese. They want to know the total of each one. They want to know what expression or what math problem shows that. So we're looking for, again, we're looking for these two there to combine. 3 over 12 plus 5 over 12. That's basically what we're looking for, is an equation that shows 3 over 12 plus 5 over 12. Let's look at this one. 3 is 3 plus 4. That's not what we're looking for. We're looking for 3 plus 5. This is 5 plus 4. Again, we're looking for 3 plus 5 or 5 plus 3. Not what we're looking for. G. 3 over 12 plus 4 over 12. We're looking for 3 plus 5. This is not it either. Oh, did you look at J? 5 over 12 plus 3 over 12. And we're looking for 3. I said earlier, 3 over 12 plus 5 over 12, or the other way around, because if you add them the other way around, it's still the same thing. It's still 3 plus 5, or 5 plus 3. It's still 8. And this is our answer. This gives us the answer we're looking for. 5 over 12 plus 3 over 12. 5 over 12 is the cheese. 3 over 12 is the pepperoni. That's exactly what Jay is telling us right here. Now they're not. We could do the math on this because the denominator is the same. We can just add it straight through. So 5 plus 3 is 8, and the common denominator of 12. So 8 out of the 12 are either pepperoni or cheese. All right. Does that make sense? I'm going to run it by really quick. So again, they want to know, so this is the total amount of pieces, right? The one we counted 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12 total pieces, that's the common denominator in each one. They want to know how many are pepperoni and cheese, which is said in this question. Like which expression or math problem could be used to determine the fraction of the slices that were pepperoni or cheese? And they want to know the total for pepperoni and cheese. 3 over 12 plus 5 over 12. 3, this is 5 plus 4, not what we want. 5 plus 4, not what we want. 3 plus 4, not what we want. 5 plus 3, this is what we want. That's our answer. All right, thank you. On to number 3. Antonio has the quarters shown below. Let's count them. These are all quarters. They have different faces, but they're all the same thing. This is the opposite sides of the same coin. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 total coins. Whoops. 9 total coins. He pays 75 cents for a package of bubble gum at the convenience store. What fraction of the quarters of Antonio's quarters are left? Now notice they all, you see, if you look here, all the denominators are the same. They all have 9, right? That's because there are 9 total coins, right? Now 75 cents, this is where it takes a little bit of evaluation. 75 cents, each quarter is 25 cents, right? 25 cents. How many quarters do we need to make 75 cents? Well, 25 plus 25 is 50, right? And then 50 plus 25 is 75. So we need 3 quarters. Did you see how we did that? There's 2 ways of doing that. So you can do 25 cents times 3, which is 5 times 3 is 15, that's right. And then put the 1 over here, whoops, 1 over there. 2 times 3 is 6. 6 plus 1 is 7, which is 0.75 cents. Or you could just count them up like they're in your head if you want. That's how I do it, because I've been through this for a while. So 25 plus 25 is 50. 50 plus 25 is 75. So that's 3 coins. We're going to cross out 3 coins. These are the coins that he used to pay for the package of bubblegum. They want to know what is left. So out of the total 9, he used 3 to pay for the bubblegum. Let's count how many are left. 1, 2, 3, 4, 5, 6. So 6. He used 75 cents to pay this. These are all gone because he used the 75 cents to pay for the bubblegum. What's left? 1, 2, 3, 4, 5, 6. 6 out of 9. So 6 over 9. This is not 6 over 9, this is 3 over 9, not what we want. Oh, here we go. C, 6 over 9. D is 5 over 9, that's not what we want. B is 2 over 9, that's not what we want. That leaves us with this answer. Again, that's how 75 cents you used to pay for the bubble gum. 1, 2, 3, we cross those out, they're gone. They're no longer here. How many are left? 1, 2, 3, 4, 5, 6. 6 out of the 9, and that's our answer. All right. On to number 4. Sarah's mother wants to bake a cake. her recipe calls for 1 2/4 cup of brown sugar. That's represented here. 1 whole cup plus 1, 2, 3, 4. 2 of the 4. 1, 2, 3, 4. 1, 2 is sugar. So 2 of the 4 total. So 1 whole plus 2/4 cups of brown sugar, which is said right here. And 3/4. 1, 2, 3, 4. That's the denominator, right? 4 total. 3, 1, 2, 3 of that is white sugar. So 3/4 cup of white sugar. Right? That's what they're telling us. So 1 2/4, 3/4. 1, 2, 3 of the whole of the 4 are white sugar. They want to know what is the total amount of sugar required for the cake recipe. So they want to know, when you hear the word total of something, it means add them together. So this plus this. Now there are two ways of doing this, right? I'm going to show you the visual way. So this is what it looks like. So we're going to count the fourths, right? 1, 2, this is just of what is sugar. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 fourths, right? 9 basically segments. So you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/4 of total sugar, right? That's basically what we're looking for. Now 9/4, there's no, so you look at these answers here they gave you. 2 1/4, 3 1/4, 3/4, 1. None of them show 9 1/4. So that's okay though, because 9 1/4 can also be written in other ways. It can be written as, so how many 4s are in 9, right? So we just count them. 4 plus 4 is 8, right? So we know there's 2 4s in 8, right? So that means we put 2, right? Because there's 4 plus 4 is 8, right? That there's 2 4s in that. Then there you have 1 left over. So another way of looking at this is, and you see the answer right here, right? So 4 times 2 equals 8, plus 1, which is the 1 left over, plus 1 equals 9. So 4 times 2 is 8, plus this number equals 9. That's how we get the same answer right here, 9/4, right? Knowing that, we already know our answer, right? Because there's only one that says 2 1/4, and that's this one, that's F right here. That's my phone ringing, don't want to plug in. So that's the answer here for F, right? This is just going to get annoying. That phone is just not going to stop ringing. Anyway, that's going to bother me, but whatever. So now the other way to look at this is to figure out, okay, well, we know we're adding two numbers up, right? 1 2/4 plus 3/4, because they're like looking for a total. This is the question they're asking, total. What is the total amount? So they want to know what these two are added together. So we're looking for something that adds them up. If we just look at this initially, look at H. H is a minus. This is a minus. So we know that's not the answer, because they were not looking for something to subtract. Same with J. We're not looking for something to subtract. So you see this is subtraction sign? That's not what we're looking for. We're looking for addition. So these two we can immediately cross it, because they're looking for subtraction. So it's either this one or this one, right? And when doing the math, we said we counted the total fourths, which again we said was 9/4, right? We figured that out by looking at what's one of these two answers. We already know it's this one, but we're going to go through the problem anyway just to figure out a different way of looking at this. In order to find these are the same equations. 1 2/4 plus 3/4. 1 2/4 plus 3/4 equals one of these, right? Well, so we're going to let's do this. 1 2/4 plus 3/4, right? And 4 times 1 is 4 plus 2 equals 6. And then we add this one right here, right? So 4 times 1 is 4 plus this number right here, 2, because this is right here, right? 4 times 1 is 4 plus 2 is 6. That gives us the 6. Plus 3/4 is 9/4, right? So these are both the same thing. This is the same equation. That's that. Okay, but again, we're looking for the answer of 9/4. This is our answer we know is true. One of these answers equals 9/4. 4 times 3 is what? 12, right? And 12 plus 1 is 13, and then you just put the 4 underneath the denominator. So this answer right here equals 13 over 4. So that's not what we're looking for. Let's look at the other one. 2 times 4 is what? 8. 8 plus 1 equals 9. Put the 4 underneath. That's our answer. So we know this is our answer. We come to that solution in different ways, but that's basically another way of looking at that answer. Okay, so basically, again, our answer is F, and we figure that out on our own. Okay. On to number 5. The table shows the number of coins in Amanda's wallet. This is Amanda's wallet. So we see 6 pennies, 1 nickel, 3 dimes, 5 quarters. Right. So in order to get our denominator, we have to add all these up. Right. 6 plus 1 is what? 7. Right. 6 plus 1 is 7. 7 plus 3 is 10. That's right. And 10 plus 5 is 15. So there are 15 total coins. Right. That's going to be our denominator, the bottom number of this equation. All right. So this one, 6 will be 6 over 15 because there's 15 total coins, right? 1 is 1 over 15, right? Because again, the denominator total number of coins is 15. We figured that out earlier. Dimes are 3 over 15, and then quarters are 5 over 15, right? So this is how we're coming up to make these into fractions. Let's look at the question. Which equation can be used to find the fraction of coins in Amanda's wallets that are pennies, nickels, or dimes? Pennies, nickels, or dimes. We don't care about quarters. We're not asking about quarters. We just cross that out. So we're looking for, basically, we want to know which ones are these. 6, because there's 6 right here, right? So we're looking for an equation that says 6, these 3 numbers. This one right here. I didn't know you did that. Wow. Anyway, 6 over 15, 1 over 15, and 3 over 15. Those are the 3 numbers we're looking for. 6, 1, and 3. The numerators. The top numbers we're looking for is 6, 1, and 3. And we want them to add up, right? Now, looking at these, right, we know 6 plus 1 is 7, right? Plus 3 is 10. So we want to know, let's write out the equation. Before we get down there, we're going to look at we want to know what equation we want it to look like. So we wanted to know which of these are pennies, nickels, or dimes. So we want it to look like 6 over 15 plus, right, plus, because we're looking for a total, plus 1 over 15 for nickels, right, penny, these are pennies, these are nickels, plus 3 over 15 for a total of, what do we say, 6 plus 1 is 7, 7 plus 3 is 10, so 10 over 15. So we're looking for an equation that looks like this. 6 over 15 plus 1 over 15 plus 3 over 15 equals 10 over 15. Now let's find our answer. Remember, we're looking for 6, 1, and 3. Those are the numbers. Those are the key numbers we're looking for. 6, 1, and 3 on the top. So we can just basically start taking some of these out. 6, right? They all have denominator 15. So 6. Remember, 6, 1, and 3 is what we want. 6, 1, 3. This is 6, 1, and 2. No. 1, 5, and 6. That's not what we want. So we're looking for 6, 1, and 3. No. 3, 5, 6. No. That's not. We're looking for 6, 1, and 3. No. Look at D. Remember, 6, 1, or 3, or 6, or any combination of those. So it could be 6, 3, 1, 1, 3, 6. There's a whole bunch of combinations we can make this. Basically, we want these 3 numbers to show up. 6, 1, 3. Then what do we say our total was? Right there. 10 over 15. That's what we want our total to be. So we have 6, 1, 3, and 10 for our total. This is our answer. That gives us exactly what we're looking for. And that is number 5. Okay, now I kind of went these through a little quickly, but I'm sure you guys are keeping up. If you have any questions, just rewatch the video. If you have any comments, feel free to leave them. Thank you.